Graph the function shown, identify the period, domain, and range. F of x equals secant of 2x, then minus 3. Secant function and cosine functions are reciprocals of each other. So this graph is going to be based off a cosine function graph. So what I'm going to do is I'm going to graph g of x equals cosine of 2x minus 3. Then we're going to convert it to a secant function. First step is determining the period of the function. Now the period for a secant or cosine is 2 pi over b. In this case it's 2 pi over 2, which is pi. So the period is pi. I'll write that down here. Okay, now this cosine function is translated down 3. That means the midline is going to be at negative 3. Let me just go ahead and draw the midline down there. Okay, switch colors. Now relative to the midline, the cosine starts one above. Then there's an intercept, then one below. So what I'm doing here is I'm graphing this cosine function as a translation relative to the midline instead of relative to the x-axis. And this should work out just fine. Okay, now let me just sketch what this curve would look like. Okay, well there you go. That's a graph of g of x equals cosine 2x minus 3. So now we need to make it a reciprocal. So any point that has an intercept with a midline is going to become an asymptote. Change the color to red first. Okay, we're just going to draw the curves for the secant function based off of those. So we're going down that way, up that way, and just keep in mind this is a rough sketch. I mean, you want to try and make it look as nice as you can, but you have to be super precise. Okay, so the red, that's the finished graph. F of x equals secant 2x minus 3. Remember, it's the reciprocal of the cosine of 2x minus 3. Okay, so let's talk about domain and range. The domain. X is an element of the real number set, such that, and we're looking for asymptotes. We have asymptotes every, it looks like an interval of pi over 2. But the pattern starts at pi over 4. So x cannot equal pi over 4 plus pi over 2 n. That'll cover the asymptotes. Because you start at pi over 4, and then you're adding or subtracting pi over 2 from that one. And the range, this one will actually be easier in interval notation because you have all negative values up to and including negative 4, and then you start again at 2 and then continue in the positive direction. So your interval is going to be negative infinity, comma, negative 4, union with negative 2, comma, infinity. Okay, so that is your range. And try to think of what this says. All negative values up to and including negative 4, that's where the local maxes are. and then you start again at the local mins at -2, and then continue on up in a positive direction. And this is just a fancy way of saying there's a gap between -4 and -2 where there are no y values. Okay, so there's the graph, period is pi, domain and range are shown here.